Okay, let's record and let's start. So today is the last varsity session of this academic year. So starting from tomorrow, it will be the summer camp. Okay. And very importantly, um, today we will talk about the application of the inequality in geometry settings. There are a lot of things very important that we need to consider when we talk about applying inequality to geometry. And today, most importantly, we will be talking about the set of idea that is for a triangle. Quick review. For a triangle, we know its two sides A, B add up to be greater than C. And any two sides of the triangle add up to be greater than the third side, which is A plus C is greater than B, and B plus C is greater than A. Okay, that's one part. And the other part is A minus B would be less than C. A minus C is less than B. And B minus C, suppose B is longer, is not as long as A. Okay. Hello, Justin. So we're talking about the use of triangle, and the use of the three sides in the setting of, hello, Dwayne, in the setting of a triangle. And let's keep working on that. So in this setting, let's take a look. Why A plus B is greater than C? The common knowledge here is we will oftentimes say, let me make it larger. The common knowledge we oftentimes say is the length of the segment between two points makes the shortest connection. The length of the segment between two points makes the shortest connection. Guys, take very good notes. I think this makes a lot of sense and it's pretty easy, right? Why? Because when we have A and when we have B, of course, when you connect them this way, it's shortest compared to when you connect them this way or this way or this way. Make sense? Yes, Dwayne.
I joined a bit late.
Yeah.
Um, what is this?
What's that?
What is this?
So yeah, we're continuing yesterday's topic from JV. So today we're talking about using the inequity in geometry. So I was talking about for the three sides of a triangle, A plus B is greater than C. So Justin, I ate almost the same thing 1 hour ago. I like the red part the best.
Me too.
Yeah. And so in this regard, we're trying to calculate a lot of things that try to make use of this rule. By the way, this rule that I am putting in thick yellow frame is the most important, and today we'll use this a lot. One more time. Between A and B, the connection made by the segment is the shortest. Anything that's not the segment, in other words, anything that's not a straight line, will be longer. Yes, Chen?
Can I go to the bathroom?
No, you cannot. That's rude. Okay, keep going. So let's continue. And in that sense, we say that We try to really connect the segment when there's no segment for us to make. Dr. Dong, what are you talking about? What do you mean we try to make a segment when there's no segment? Take a look at this. This was actually where I stopped yesterday by Junior Varsity, and I was telling a few of you. Dwayne, you were there yesterday. I think Harry and Hannah were there, but I don't see them here today. So for example, I have now point A being a factory and point B being another factory. And this line is the river. Now I'm asking you to drive from point A and reach the river to take water and then carry that to point B. Which part of the river should we stop? Which part of the river should we stop is the question. Okay, this line is the river.
B is below A.
B is below A, yes. Those are two random lines.
Oh,
The river is random, the 2 points are random. There's nothing special about those 2 points location. Thoughts? Michael, thoughts? Michael, you can hear me all right, right? Okay. Michael, from time to time, I check with you because you have the background blurred. So when you are very far from the camera, you become the background. So you become blurred. So I can't see you. Okay, where is that? I have actually 2 ways to do that, and we have exactly the same conclusion. The first way to do that is, okay, let me copy and paste this graph. So we have exactly the same thing. After we finish this method, we go to the second method, okay. The first method is, guys, watch. We find the symmetric point of B against the river, B prime. And we connect A, B prime, where the connection intersect with the river P is where you should take the water. Dwayne had a weird look like, why? What? What is it?
Why,
Dwayne,
why does that work?
why would that work, guys? So first of all, would you agree with me that, for example, this point, we call that H, okay? The foot. And would you agree with me that triangle PBH and the triangle PB prime H are congruent? PBH and PB prime H are congruent for sure. Why? B and B prime are symmetric. So we know BH and B prime H are the same. Are we okay? And this angle BPH and this angle B prime PH are the same. And PH are overlapping. They share pH. So the 2 triangles, the top triangle and the bottom triangle, are the same. Are you with me? Good, good. The top triangle and the bottom triangle are the same. And you may ask me, so what? So guys, just now we want to make sure AP plus PB is the shortest. Is that right? We try to find AP plus PB being shortest. Now I change that to AP plus PB prime being shortest. Why? Guys, take a look. Those 2 in the yellow box are the same. PB and B prime are the same. Are we okay? So, and why those two are the same and that matters. Now you see, now I am I'm connecting AB prime together. So it's a straight line. What if now I have a different line that is going this way? A, and now it's not P, but Q. Do you think AP plus PB prime being short or AQ plus QB prime being short? Which one's shorter? Can you tell?
P1.
The P must be short. Why? See, AP plus PB is just AB prime. But when you make the Q, it's going not a straight line, but you are going into a triangle. Remember, this plus this is greater than this. Good, good. So the thing we do, how we do that is we do the flip version and we connect a straight line. That's how we do it. Good, good. And you may be like, okay, so why do I have to do the symmetric point of B? Can I do the symmetric point of A? Yes, of course. Let's see. I do the symmetric point of A. And I connect A prime B, and that intersect with the river at P. This P and the P at the top must be the same, just like this method. Those two P's you find are exactly the same. So you can do the symmetric point of A or B. It does not really matter. Okay? Xichen, I'm talking about go from A and reach the line and then go back to B. What's the shortest of the path? Are we okay? So one more time, we do the flip side. We do the symmetric point and then connect those 2 points, and we find where the shortest portion would be. Let's not worry about the calculation at the moment. I want you guys to really be able to get the gist of what do we mean by the straight line is the most important thing. Can we do another practice? Let's do another practice. Okay, guys? Can I do another practice with you? Okay, let's say, for example, now I have this wall. Okay, I want to move from B to A, but I need to touch this vertical line first. Okay, for example, we're talking about a city. Okay, we're talking about where on this road, this is a road, where on this road we will need to set up the, let's say, the UPS station. So every day, you will start from B, which is the airport, and go to the UPS station, and then go to A, which is the train station. So every day you need to go from the airport to UPS, and then UPS to the train station. Where should the UPS station being located on this road? Can you tell? Think about that. Think about that. Where should we settle the UPS station? Thoughts? Just
Can I
unmute. We
annotate?
only have 4 people, so just unmute yourself and say whatever you want to say.
Can I annotate it?
Yes, you can annotate.
Okay.
Okay.
And then I know it's a straight line, like right there, somewhere.
Okay. Got it. So you're making the symmetric point of B to B prime and connecting AB prime. And the point AB prime intersect with the road is where the UPS should be. Exactly. In this case, B to UPS and then UPS to A has the shortest sum of the path. Okay. Now I'm asking you guys to prove. What if now I put the point M? Then we say point M is not the best way. Can you prove point M will have a bigger BM plus MA? Can you prove BM plus MA is greater than B UPS plus UPSA? Can you prove that? Use math. Proof. Can you prove that? Not really? See, now we connect BM. And we also connect B prime M. We know that because as B and B prime are symmetric. Therefore, we know BM and B prime M are equal. Does this make sense to you? B and B prime are symmetric, so BM and B prime are equal. So now BM plus MA equals B prime M plus MA. Now let's see. B prime M plus MA, let me use a weird color. Okay, let me use green. See, B prime M is here. Let me use very thick green. This is B prime M. This is MA. The two of them add up together. The green and the green add up together is, of course, longer than the third dotted green line, which is just one side of the triangle. Remember, we just reviewed two sides of a triangle. When you add those up, it's longer than the length of the third side. That's how. Are you guys following? Is this too hard or easy? Good? All good? Michael, you good? I can't see you again. All right. So very good. So that's why we try to find the shortest. And another thing I want you guys to practice a little bit before we can continue with the real calculation. Okay? I'm drawing this line because chances are Hannah and Kevin may need the recording, so I'm trying to not write that to the other side of the line. Okay, so I'm asking you guys another very interesting question. Not relevant to the first question, but a general concept, okay? Guys, I have a cubic. This is a right cubic, a perfect cubic. With the edge length being 6. The length of the edge is 6, okay? I'm asking you, now I am connecting point A with point C prime. Which point of B prime would this line go through so that my jaw of the line is the shortest? Now I'm drawing a line between A and C prime. Where does that intersect with B prime to make my drawing the shortest? Are you with me? For example, guys, take a look. Can I draw that like this and this? Do you think this is the shortest? Or do you think this is the shortest? That is, I draw to the bottom and then to the bottom and then to this one. Really use your imagination of 3D. Do you think that's the shortest? That distance is apparently 18, which is the sum of 3 edges. That looks like not the shortest. So what is the shortest point? Let me finish writing that A, B, C, D. Guys, focus on class topic. Focus on class topic. From A, B, C, D, from A to C, where do you think I should draw that line? Can you think about that? Apparently, that line made a turn, right? Because that line needs to stay on the surface. So on the front surface, and then it turned to the right side. Where should that be? Think and please send in the answer. This is a bonus $2 question.
How do you want us to send it in? Like what?
Just
Like,
explain, just say where that is and your rationale. You don't just send in an answer. For example, you say it will intersect with B prime at point P, and point P should be how far away from B and how far away from B prime, and why that's the case. You can just elaborate in such a way.
How is there only like 5 people in this? I just realized.
is it summer?
Wait, you guys have school off?
No, like we're traveling. People like leave.
Oh,
Come on, guys, let's
I still
focus
have
on
like a
topic.
week of school left.
I have like 3 weeks.
Come on, where? Sending the answer, guys. This is not a hard question. Sending the answer. And it's $2.
I don't know.
If only one person sending the answer, and if that answer happened to be correct, then the bonus doubles. You guys know the rule.
So we're trying to find where P is so like it finds the minimum distance.
Yes.
And it's between.
Justin, I need to specifically know where the point is, where that intersect with B prime. Justin, you send me your thought process, which is appreciated, but I need the answer. think. Three, two, haha, okay. One, ding, ding, ding. Justin, you were, when I counted 3 and 2, you were the only one who did that right. So I was thinking, okay, Justin got $4. And then Michael sent in the correct answer. So you both, each one got $2. Okay, Justin 2 and Michael 2. Okay, this is a hard question. How do we do that? See, we're now trying to get from A to C prime. So I'm unfolding this surface. I'm making this front surface still being the front surface. Guys, look, it's A prime, B prime, and B. But now I am unfolding this right side, C prime. I put that to the front. And now you see I am connecting A with C prime. That goes exactly the middle of B prime. Why? Because this and this equal. In other words, this B prime is the midline of the triangle A prime, C prime. Are we okay? Now, another question. What if now, instead of connecting AC prime, I'm connecting A and D prime. A and D prime. And I am now asking, what are the 2 points? It will intersect with B prime, and C prime.
Like how far the point is through B and B prime and C prime?
Yes, exactly. It will connect with B prime at P and C prime at Q, and then go to D prime. The requirement is it must go through the cube. It cannot go to one surface. Otherwise, you just directly connect A and D prime on that left side. You don't even need to go around. Are you forward with me? You see, I'm now trying to get A and D prime, but my requirement is you go through the 3 sides. This is very normal. Like, guys, when you guys are on highway, do you see a lot of trucks? Those trucks have all the ropes or, cords connecting or fixing the stuff, the cargo or whatever they are carrying, right? They oftentimes need to make sure the cord is the shortest. However, the cord will need to go through all the surface of the cargo to make sure the cargo does not move. Make sense? Right? When a truck is carrying let's say a log or a lot of big trunk boxes, you need to go through the different surfaces of the freight to make sure that one stays rest on the truck when the truck is moving. So how would that be done? Think about that, guys. Now, apparently, we're not unfolding just one side. We're kind of unfolding all the sides. So the first part is A prime, B prime, B. And the second part is
Wait,
B prime,
where did your
C.
screen go? I can't see your screen.
I don't know what happened.
Like, I can't see your screen.
Sorry, let me reconnect, okay? It's just I don't know what happened, but can you guys see now?
Yeah.
All good? So keep going, and this last side is C, C prime, and D, D prime. So now we're literally connecting A to D prime. I'm asking where is P and where is Q? 3, 2, 1. The edge is 6. Ding. Ding. Is someone trying to send in the answer or no? Ding. All right. Justin's answer is the only correct answer. So Justin this time makes $4. Okay. Dwayne, you're giving thumbs up to, is that your parents?
Yeah,
Say hello to them for me.
they already left.
Okay. So see, take a look. Now this is 3. So B prime and C prime bisects A prime and D prime. In other words, P and Q would also tricept AD prime. In other words, AP equals PQ equals QD. Good. So this side must be 2, this side must be 4, and this side is 4, this side is 2. And we're trying to make those connect and make sure those are even. Okay, so now let's start with question 1. Literally work on question 1. Go. Question 1, 50 cents. I know it's easy to Google that. It's easy to Google Lens that. It's easy to ChatGPT picture that. So I need you to use our method just now, which is the AOPAS method. Use our method learned just now. Okay. Says the riverbank is now line y equals 0. Do you know what is y equals 0?
The x-axis.
Yes, correct. Thank you, Xichen. That's the x-axis. That's exactly the x-axis. So it's now connecting A with a point at x-axis and then to B. Where do we find that and what's the shortest distance? One more time, this one is 50 cents. Show the reason. Let me draw that. Guys, and this is where I need you guys to, when you draw that, please don't draw that randomly. For example, do you think it make sense for me to draw A like this? Do you think if I draw A like this, it's makes sense?
No.
No, why?
Because the y value is greater than the x value, so it has to be taller than in Islam.
Yes, exactly. Thank you so much. A is 2, 6. You cannot make it like that. It should be something like this, right? And B is 12, 3.
Wait, did you ask for like our thinking for it?
Yeah, I need you to not only give an answer, but also briefly explain what you were doing, how you got that. So A is 2, 6, and B is 12, 3. Find the P that minimize AP plus PB and also tell why. So think about what symmetric point do we get. First of all, you need to touch the x-axis. So x-axis should be the symmetric axis that you use as a reference to draw the symmetric point. Does that make sense?
Don't look at my answer. I pressed enter on accident.
So do you want me to take that or
No, 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 do not take it. Do not.
do not take it? Okay, keep going, guys, all of you. Is that a peach, Dwayne, or apple?
Peach.
I like peach.
I'm allergic to peaches.
Oh, you're allergic to peaches? I'm sorry.
Here, take it.
I mean, like the hair of it, like the skin.
Okay, guys, keep going. Keep going. Do you find that finding the distance, minimize the distance is easier, but finding the location of the point is not that easy? There are much calculation needed. Here's a hint. Do the symmetric point. You can do the symmetric point of A or B, it doesn't matter. At the end of the day, they interact at they intersect with axis x at the same point. So B's symmetric point is 12, -3. And you connect them. You connect A and B prime. The point P is where you need to get. So now the tricky thing is you literally need to calculate what is the coordinate of point P and what's the distance of AB prime. Distance of AB prime is not that hard. We know that. Got it? What's AB prime? Remember the distance formula? x1 minus x2 square plus y1 minus y2 square, and take the square root of that. And in this case, what is it? 2 minus 12 square plus 6 minus negative 3 square. So the distance is, come on, do the calculation.
181 square root.
Root 181 is correct. Thank you, Justin. And what's a coordinate of P? Can you do the coordinate of P? Yes, both Michael and Justin are correct. So 0.5 Justin and 0.5 Michael once again. How do we get that? We try to now find the function of the line of AB prime, and then get the intersect. Or Xichen, that's also don't use fraction. Xichen, this time I will grant you the scholarship, but next time don't use fraction. It's not physics, it's math. So don't say 8.67. I know you like 6.7, but please say 8 and 2/3. In physics, we do fraction, okay, Xichen? In math,
That's a decimal.
0.67 is not the same as 2/3.
Wait, that's a decimal.
Yeah, so use fraction, do not use decimal. Is
Yeah,
what.
you said don't use fractions.
Oh, sorry, I said it wrong. What I meant is do use fraction, do not use decimal. In physics, we use decimal. In math, we use fraction. Okay. Because in physics, there's no way you can get 2/3 forever. Okay. But in math, you can. So I'm doing that. Okay. And keep going. So, but Xichen, this time I will grant the
Scholarship.
scholarship for you, 0.5. However, the thing is how we really get the point of P. There's so many ways. The first is, I know you guys are very used to set the function of the line being mx plus b and pull in 0.26 and 0.12 negative 3, get the value of m and b. But I want to once again tell you guys another way to do that is y minus y0 equals m times x minus x0. Okay, that's how. That is when the slope of a line is m. That could be done by y1 minus y0 over x1 minus x0. That is the slope, and it go past a point. We can get the slope of the line. For example, now the 2 points are 12, negative 3, and 2, 6. So we can use 6 minus negative 3 over 2 minus 12. So that is 9 over negative 9 over 10. This is the slope. And it goes through a line, 0.26. So that's y minus 6 equals negative 9 over 10, x minus 2. Well, who's that? Oh, Harris.
Harris, you're late. Very much late.
Yeah. He caught me. I'm like, I was doing the writing and I heard the doorbell. Okay. And in this case, when we're talking about we're trying to find the coordinate of P, we're actually trying to take the coordinate of P, we're trying to take the y as 0. So now it's -6 equals -9/10 times x minus 2. We can solve for that. X equals 26/3. So the coordinate of P is 26/3 and 0. Okay? Harris, can you hear us all right? Okay. All right. So keep going. Now, question 2. Go. Question 2 is a little bit harder, so bonus $1. Go.
Wait, but we do the exact same thing, right? Like the same way.
What's that? Say that again.
But it's
Xichen?
like this, I feel like it's the same format.
It's almost the same, but it's not that easy because now that line is y equals to 1. So it can be challenging when you're doing the
Reflection.
reflection, if that makes sense to you.
So are we reflecting over y equals 1 or y equals 0?
Y equals 1. Now the
Okay.
water line is y equal to 1.
Okay.
So even though Xichen said it's similar, I would argue it's a little bit more challenging.
No, what I meant was like it's the same like way to solve it.
Yeah, true. That is true.
Just to make sure I'm using fractions, right?
Yes.
Okay.
You can use decimal, it's just we will throw garbage at you.
Yeah.
No, Michael, me, Justin, Harris will throw garbage at you. Xichen will throw peach at you.
I will throw peach at myself.
No. I mean, Dwayne will throw peach at you.
I'll dodge it.
Harris,
Yeah, you're not
for your
dodging,
knowledge.
bro.
Harris,
You
for
are
your
not
knowledge.
dodging me.
For your knowledge, Xichen is allergic to peach.
Do we still have to make a brief explanation, or was that fine?
This time, I think since we're on the same page, you don't need to. Just give me the answer.
Is that right?
I can't announce at this moment. But so first of all, once again, we need to draw the points correctly. A is somewhere here. B is somewhere here. No, B is a lot. Why I'm doing that? B is higher. And the line y equals 1. The line y equals 1 is this green line. This is y equals 1. So Harris, this is specifically for you because you joined late. And B is 13, 4. So we try to find the symmetric point of B against y equals 1. This is trickier because against y equals 1, B prime has the x coordinate the same, but the y coordinate is at -4? No. See, 4 over 1, the distance is 3. So this B prime to the green line, the distance is also 3. But the green line has the x coordinate of 1. So B prime is 13 and 2. See?
It's -2.
Oh, yeah. 13, -2. Oh, well, sorry, guys. Well, here's my head.
Hi.
Okay. All right. So now we connect A and B prime. And it's now asking where that line will touch this green point, P. So we find the function and we also find the length of AB prime. The length of AB prime is pretty straightforward. It's actually, once again, root 181. I'm looking at, and the coordinate is 29 over 3 and 1. Okay, so let me see. Xichen, Justin, Michael. No, Xichen and Justin is correct. Michael, I think the calculation had some problem. It's still root 181. So Justin 0.5, Xichen 0.5. Keep going. Now let's do a brand new type of question. Let's look at question 4. But for question 4, just now I already taught about the cube and how we go around the cube. My hint is I will quietly, without saying anything, I will quietly draw what this question is about. So if you need my hint, just look at the screen. If you don't need my hint, just work on the question, okay?
Do we still need to put in our work for this one?
Yeah, just putting the answer to this one. Just putting the answer for this one. This one is almost identical to my previous example for you guys, but my example previously was focusing on which point on the edge it will cut through. But now this question is focusing on just the shortest path. Harris, a reminder, your answer is not the simplest radical form. We're talking about root 45 here. Okay, Dwayne, how about you? Let's unfold that. This is A, this is B, this is 6, this is 6, this is 6. Now it's asking what is AB. Dwayne, can you send in the answer? We have 6 and we have 12. So the correct answer is, guys, 6 times root 5. If we just think those as unit triangle, this is 1 and this is 2, then this is root 5. So multiply that by 6 and 12, so this is 6 times root 5. Harris, when we talk about the simplest radical form, we're talking about you can no longer calculate the square root. Are we okay? So just now when you had a root 45, it needs to be written as 9 times 5, and that 9 can get out. So root 45, simplest radical form of that is 3 times root 5. Okay? Okay, so for this one, I have Justin 0.5, Suchin 0.5, Michael 0.5, Harris 0.5. Guys, keep going. The next question. How about this one? Haha, this one is a little bit more interesting. There are quite some calculations to do. This is no longer a cubic, so you need to plan the best route. Justin, what is Mabai?
I mean, so maybe.
Thoughts, everyone? Now this is not a cube, so different way of walking may be different. So we have a 4, we have a 6, and we have a 9. How do we go? It's once again going through the vertex. Okay. Now it really depends on which vertex. So it can go through, right? 6, 4, 6, 6. It can go through 4, 6, 6. It can go through 6, 4, 4. Make sense, right? It can go through 4, 9, 9. It can go through 6, 9, 9. Boy, this is the most horrible one. It can also go through 9, 4, 4. It can also go through 9, 6, 6. Boy, this is also a horrible one. Make sense? Just now the cubic making it go through which side doesn't really matter, but now you want to really go through the shortest side. Can you please tell me which one is the shortest? Well, we can absolutely tell as long as we're involving 9, it's not the best. So this one is not good. 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 So either is 466 or 644. Which one?
Wait, how do you even do that?
The thing is, it is 4 by 6 by 9, right, Dwayne?
Yeah.
But it didn't say which vertex are we talking about. We're just talking about the two opposite vertex.
Oh,
So the shortest is apparently the 6 and the 4. The 6 and the 8. So it is 10. It's still better than the 4 and the 12. Okay?
can you draw that?
What's that?
Can you draw that on the cube? A rectangular box.
Yeah. If we have the 4 open like this is 4 and this is the 6.
Opposite vertex. So you can basically decide what your meaning of opposite vertex is?
Yes,
How are we supposed to know?
we find the shortest. It's asking the shortest, see? The shortest possible surface distance. So it is 10. Yeah, let's do another practice so you guys may feel more comfortable. Can we do one more practice? No, I saw Harris like, no, let's not do that. Guys, do you want one more practice? Or let's take a break and work on a brand new type of topic. I need to teach you guys. If we have time, we'll go back. But let's do this brand new practice first. Question 7 is the most complicated manner for today. I need you guys to understand how we work on this. Please do. Take a look at this. After you finish reading that, I'll just start to draw. Ideas? A rectangle has corners. The original point, 10, 0, 10, 8, and 0, 8. Okay, and the point A, which is 2, 7. 2, 7 is here. And point B is 7, 6. Is somewhere here. A path starts at A, touches the bottom side, which is the x-axis, and then touch the right side, x equals 10 at Q, and finish with B. And it is asking find P and Q. Guys, see, this is a super hard question. We connect. So it's almost like a bouncy ball. It's almost like a bouncy ball when we first start with A, and after we start at A, we touch the x-axis, and then we then bounce at the right side of the rectangle, and then go back to B. Wow, it's hard. Do you guys know how to do that? Think. Can I give you a hint? Thoughts? Do you know how this is done? This is the P and this is the Q. If you guys understand what I just did on the screen, bravo, Justin. That's correct answer. Wow. Impressive, Justin. I'll put down $1. Impressive. You guys know what I did? Okay, let me give an explanation. First of all, this is like two bouncy balls. It's not bouncing once. I'm sure you guys played this type of video game on your cell phone or on your tablet or on some of those, what, PS5 or something. By the way, do you guys play those?
I only
Somehow?
play on laptop.
Yeah, something like that, those bouncy balls. So it's bouncing different edges. And now it's adding the different parts and make sure the sum of the distance to be the shortest. That's Michael, that's correct. So I will add $1 for you too. It is really difficult where in this case, guys, keep in mind, here is the rule of thumb when doing this type of question. Whenever there is a bounce or whenever there's a reflection, there is a symmetric point. See, it says it touched the x-axis first and then touch the thick green side. This very thick green side for a second time and then go back to B. So its step is from A to P, from P to B, from P to Q, and then from Q to B. Now the pink, can I call that pink? The sum of the three pink segments are the shortest. How do I do that? Guys, take a look. I first take the symmetric point of B to B prime prime. And then I take that, see for B is 7, 6. So B prime prime is 7, negative 6. And then this thick red line, the thick green line is x equals 10. So the other side of the reflection is 13, negative 6. Why? Because 7 towards 10 is 3. Guys, this is 3, and the other side is also 3. So we find the other side, and we find the point, and now this is the double reflective point. We can now connect A and B triple prime. We can get the point P. And we get another reflect point of B, B fourth prime, and that connect P and the reflective point, we get the Q. Okay, we can prove that. Why? Because QB 4 primes equals QB. And QB 4 prime plus QP is a straight line. See this one? This blue thick line is the straight line. That's the shortest. And PB 3 primes, 4 primes are the same as PB 3 primes. The two thick blue lines are the same. That's why we now connect AP and PB triple prime. We get the straight line that's the shortest. That's how we did it. Not easy. guys? So one more time, if needed, put it on your notebook, please. Are we okay? As long as there is a touch and reflection, we need to do one reflection point. See here, this one bounced twice and had 2 touches. Then we do 2 reflections. Are we okay? The number of touch equals equals the number of reflection. That's how we do it. Okay. Are we good, guys? The last question for today. This one. Go.
Holy shoot!
Yo, what do you mean?
My iPad's gonna run out of battery.
You scared me, bro.
Last question. This is very similar. We have 2 points and a path, but this one touched the top side and then touched the right side. This time it didn't really touch the bottom, which is the x-axis, so it's really making the question a little bit. When you do the reflection point, it's a little bit more challenging. You can double check your last calculation. I really want to give you the bonus.
What?
I really, really want to give you the bonus. So double check your calculation. Dwayne, try to make some money.
I have no idea what's going on.
You have no idea what's going on?
Wait. I changed it. Is it right now?
I can't answer. I'm just saying I gave you a one-time opportunity to change it. Because my thing is not being punitive or accusatory of not making you guys do the question. I want you to do that right. Dwayne, I want to explain thoroughly. If you don't know what's going on, please follow my explanation, Dwayne. Watch carefully. So we have 0, 0. We have 0, 9. So this is 0, 9. And we have 12, 9. And we have 12, 0. Okay, and we have point A, 2, 2, which is here. And we have point B, 9, 3, which is pretty much here, B. And this is the frame of the rectangle. Now it's saying something is touching P and is touching Q. So what we really want to do is find out where's P and Q. P is the upside and Q is the right-hand side. Let me make it a little bit to the bottom so we have ample room to really draw that. The first thing we do is to draw the symmetric point of B against the upper side. B prime is here. And then we once again draw the symmetric point of B prime against the right side. So this is B prime. And we now connect A and B prime. Okay? This is where we find P. And we now draw the B symmetric point of B against the blue, which is the right side. We call that B triple prime. And we connect P and B prime, prime, prime. That is the Q. So now we successfully find P and Q. Take a look. This is the path. The path, I draw that in thick green, okay? That is, we go from A to P first, and then go from P to Q, and then go from Q to B. The thick green segments add up together as the shortest sum of segments. Why that's the case? Guys, follow my explanation. Watch very carefully. Watch. P Q B is the same as P Q B triple prime. Can you see that? Look at the screen. PQB is the same as PQB triple. Got it?
Yeah.
Because that's symmetric. Guys, even though you got the answer right, I still need you to follow my process because I'm teaching you how to prove something. We're not just solving for the answer, we're proving things. Because very soon you guys will need to learn to really write the proof, not just do the ABCD. So, okay, very good. So now PQB is the same as PQB triple. So PQB triple is just PB triple. Did you see that? Q is only a stop. Got it? PQB triple is PB triple. PB triple, guys, read carefully. PB triple is PB double. Watch the screen. PB triple is PB double. PB double is here, guys. PB triple is the same as PB double. Good, good. See that? And PB double connecting with AP is a straight line. Did you see? APB double is a straight line. That's the shortest. Got it? Are we all right? Okay. Now a bonus point question. Oh, by the way, let me look at who did that right. Michael, Xichen, Justin, you are all correct. So Justin 0.5, Xichen 0.5, Michael 0.5. Whoa, Justin can buy a house today. Justin has $6, $7, $8, $9. Justin. Okay, very good. So I lied. Just now I said that's the last question. This is a bonus point question, but you don't have to do that. If you feel like, okay, that's too much, feel free to log off. But this is a bonus point question. I want to teach you guys something new. Today, everything was about symmetric to a horizontal line or vertical line, but this one is about symmetric to y equals x, which is a weird line. This one is relatively easy, but the line per se is weird. A is 1/6, so this is A 1/6. B is 7/10.
We've done this type of questions like so many times.
Oh, you've done this several times?
No, like these types of questions.
Yeah, but this line is very unique. Seven ten. Let me draw that a little bit higher. 7/10 is something. And this is y equals x. So something starts at A and need to touch this point y equals x and then go to B. I'm asking what is the shortest of AP plus PB?
I actually just did like a packet of questions before this class about reflecting over like lines.
Poor you, you just did a set of questions before math team.
Yeah, I'm not even
Varsity?
joking. I can show you it right now. It's AMC prep, and it was literally about reflecting over like lines like y equals x, y equals negative x, all that.
Okay, all right. So that's perfect. So guys,
She
take a
did.
look. How do we find that? We get the symmetric point of y, of A or B. What I want to teach you guys is how do we find the reflective point of A or B against y equals x is my question, is my thing. That is, the reflective point of A is A prime. The reflective point of B is B prime. You can tell if you connect, they're symmetric and they're perpendicular to y equals x. The thing is, what is the coordinate of B prime or A prime? That's a question. The thing is, we swap them. So B prime is 10, 7. A prime is 6, 1.
Dang
Keep
it.
that in mind. That's how we do the symmetric point.
It was so close to 6, 7.
And you connect either one of them, like B, A prime, or A, B prime. They absolutely intersect at the same point. That is the point P. The shortest distance is therefore you connect is 710 to 61, and that equals root 82. And the point that we touch is 53 over 8. 53 over 8. Don't be surprised. It's on the line y equals x. That's why the x and the y coordinates are the same. Are we okay? The thing I want you guys to learn from this question is when I have a line y equals x, and when I have a point that is 7, 10, its symmetric point is 10, 7. That's my point. Are we okay? Are we good, guys? So this is a historical moment. By now, we have finished this academic year's varsity.
Yippee!
Starting from tomorrow, it's summer camp, and tomorrow is English reading.
I am not doing that.
Okay, I know.
I'm done. I'm done. I just want my break, bro.
It's okay. So we will not see you moving in the future,
I don't
Dylan?
know.
Is that what you're saying?
No, I don't get to decide if I take classes.
Okay. Xichen, you have your hands up.
Wait, so are we still doing scholarship for the summer?
Yes, of course.
More money?
Yes, of course. So guys, I'm very happy to work with you throughout the year. We'll start the summer session starting from tomorrow. I think for most of you, I will still see you guys. Like I said yesterday, Monday is PSAT reading, Tuesday is reading and vocabulary, and Tuesday is writing and grammar, and Wednesday is junior varsity, still the same time. Wednesday and Thursday are exactly the same. Friday is scientific activities and presentation and scientific research and STEM fair. Hopefully, I will see you in the summer session, but if I don't, have a happy summer. I would say probably for most of you, I will see you not in all the classes, but in some classes. I guess that's the case. Okay. Wish you have a safe, happy summer. Bye. See you soon.
Bye.
Bye.
Bye.